Hello and welcome to another video around the mathematics program, and today we're looking at an area of probability which involves experimental data. Now you see, up till now all the calculations that we have done have been around things that we can calculate. We know, for example, the probability of getting a 3 on a dice. We know the probability of throwing a coin and getting a head. But what about something that you don't know? So the example I've chosen to mention here is, if I was trying to make a free throw in basketball, what's the chances of my doing it? Now I don't know what that is, so I might do an experiment. I will take 100 throws and record how many times that I'm successful. And then the number of successes, which would be called a relative frequency, becomes the probability. And then, so that I can then use that as data to say, well, okay, if I get 40 out of 100, my probability of getting it is that 0.4. Okay, so imagine we collect that data and we put it into table form. And let's look at an example here where we can use that. Now this example we're looking at is actually taken from part of a question from an actual NCEA paper. And someone's analysed the reaction time in Australian students, female and male, and basically we've got 97 females are under 500 milliseconds and 118 females are over 500 milliseconds. And on the males we have 77 are under 500 and 8 are over 500. And we've got 4 questions around that data there. Okay, so let's take each of these questions in turn. So I've recreated the table at the top. Now the first thing I like to do with these type of things is to put some numbers in, because I know that I'm going to be using them. So that top row, number of people, the number of females is 97 plus 18. That's a total of 115 females. Number of males is 77 plus 8. That's a total of 85. So the total number of people is that plus that, which is 200, which sounds like a sensible sample size to me. If you look at the numbers on the reaction times, the total number of people who were under 500 is 97 plus 77, which is 174. And the number of people over 500 is 18 plus 8, which is 26. And happily, they add up to 200 as well. So we're using the same data. Now the first question we're asked in this particular example is, what's the probability that a student chosen randomly from the whole sample had a reaction time of less than 500? Okay, reaction time of less than 500. That means it doesn't matter, we're not specifying what's gender, we're just saying take one from the whole sample. Well, we've got 174 students are less than 500 out of a total of 200. So that means my probability is 174 over 200. Okay, and that's the answer. Simple as that. The next one we're asked is probability of choosing a female and less than 500. Well, basically that's all focused in this one area here. Female under 500 is that group there. So that's going to be 97 out of 200 for that one. Okay. Next one I'm asked. Probability, given that it's a male, what's the probability that it's less than 500? Well, if we're told it's a male, we're only looking at that group there. And the number of males under 500 is 77. but it's only out of the male, so the answer is 77 out of 85. Okay, we're specifying we're locking in the male, so it must be out that 85, and it's only 77 of them. The last question is, if two students were chosen randomly, what's the probability that both had reaction times of under 500? So probability that the first is under 500 is equal to, well, we've done that's 174 over 200. Probability that the second is under 500, well, we've taken one out of that group, so there's only 173 left out of 199. So the probability of that and that means we have to use a multiplication, 174 over 200 times 173 over 199. And by my calculations, that comes out at 30,102 over 39,800, which I will convert to a decimal and get an answer of 0.7563. And that is how you use a contingency table.